hello everyone. Thanks for joining us for the third episode of Cloud Talks KL. I'm Amrita and I'm the lead for GDG Cloud KL. So for those of you who are joining us for the first time, just a quick introduction of who we are. So GDG Cloud KL is a friendly nonprofit community of developers working with or who are interested in learning more about the Google Cloud Platform. So we host events to create opportunities for amazing developers with similar interests to meet and also share ideas related to technology. So today, for our third episode of Cloud Talk Scale, we will be introducing you to something interesting. As you all can see on the screen now, it's going to be about building production-ready application in GKE. So without further ado, let me bring in Raju to join us in this session. Hey, Raju.
Hello everyone,
So
and thank you.
yeah, thanks a lot for joining us as well. We're super thrilled to have you on board. Um, yeah, before we get started, why don't you share with us a little summary of what today's session is going to be about? I'm pretty sure our audience would love to know what to expect today.
Yeah, well, when we talk about Kubernetes, right? So we had a lot of failure stories and lots of difficulties in handling them, and lots of things we miss for getting the application to be production ready. And comparing that with the features available in Google, or those are the features which are provided by Google as an experience for starting the Kubernetes. So I will be sharing about them for getting started with the cluster, as well as how do can we manage the applications, and how can we manage those application life cycles. And those are the things I'll be sharing today, and it's way too exciting. And thank to all of the organizers for organizing this event and for having me. So I'm way too excited for being a part of this community.
Thank you for joining us. I mean, it's definitely thrilling for us to have you here. I guess no, we would have never expected to have a speaker coming all the way from Nepal to join our monthly meetups. So thank you for joining us today. So before we get started with our talk today, we'd love to know a little more about yourself. So would you mind sharing with us a bit about yourself as well?
Yeah, sure. So I am Raju Dawadi, all the way from Kathmandu, from Nepal, and I'm a Google developer expert in cloud platform. And I've been helping companies inside and abroad for getting with the cloud transformation, for building their reliable application, and for getting their DevOps architect. So these are the things I've been doing, and also I've been building the DevOps Kathmandu community with engaging the people in the interested areas, and getting new people in the DevOps world. So yeah, it's going way too interesting these days.
That's amazing. So, without further ado, we'll jump right into your session. So, yeah, I'll just leave the screen.
Okay, so in the starting, if you are not too familiar, or you are diving into the Kubernetes or the containerized platform, so I'm gonna start with how it evolved very briefly. So in the traditional days, we used to have this operating system lying above the hardware, and we used to have lots of those racks, and there was a limitation of running multiple applications, scalability problem, different downtime. So after that, we got into the virtualized deployment. So if you remember about the VMware, where we run multiple OS on a single hardware, but that was way too slow in the starting phase. That has the limitation, like the bulk of those or the weight of those virtual machines, and those operating system as well. And gradually there evolved the concept of the Docker, which is a very lightweight platform, and we could run multiple Docker containers with the usage of very little amount of the resource into our single operating system. And we could also distribute them to multiple servers, and with the multiple and the different types of operating system, whether it be Linux or Windows or any of those platforms, those could run Docker, even the Mac OS, right? So after the evolution of the Docker, because of its lightweightness, and with the scalability, or with the demand of the workload, and with the multiple types of the workload we need to run on for our business or for our services, we need to have a platform where we could run lots of those containers within a single platform, and that is the Kubernetes cluster. So where there is a Kubernetes master which controls, or we can call it a brain, which controls all of those Docker containers, how they are going to be run on the different nodes or the different servers, where they are distributed, maybe in the multi-zonal or multi-regional or in the multiple servers as well. So those are the like things Kubernetes handle, and we don't have to worry about like how what is the actual Docker container is running, because we might be running lots of them. So we cannot remember, we cannot keep the configuration of, let's say, thousands of Docker containers running, for a different service, for a different number of the service and different types of the service. So that's where the Kubernetes maybe make it a lot more easier. And so, talking briefly about how it eases the process of our deployment, or the process of running our application. So one of the important feature of the Kubernetes we use is automated scheduling, because if we have lots of those servers running with a single cluster, and we need to have lots of those Docker containers running, so that needs, those containers need to be scheduled, or those containers need to be running on multiple machines, right? So for that we need a very high level of the scheduling mechanism, and that's what the Kubernetes does, so that we don't have to worry about where are those running, how are they performing, and all of those things, but at least they are running. So that's the feature provided by the Kubernetes. And when we run multiple services, like multiple kinds of the resources, and any point in time they could fail, so we cannot trust everything to be running every time and in the every like unlimited amount of the time, right? So we might need to replace, we might need to restart, or that could just go down or degrade. But that should not be affecting our applications which is running. So that is a self-healing capabilities where the Kubernetes performs. So let's say, for example, if we have hundreds of nodes running in there, and if one node or one of the server inside the cluster goes down, then we need the Docker containers or the pods which are running on the Kubernetes to be in the same number we want that. So that is how the self-healing works. Or maybe that could be adding the one more node after one is going down, and the rollbacks as well. So one of the very paining thing is like if there is a problem on the deployment and on the rollback as well. So for example, if we are gonna deploy lots of applications, and that could be of a different version, and we want to roll out them at the same time or at a different number of the time, and we want them to be rolled out gradually, maybe 15, 20, or 50% each at a time to a specific set of the users. So, and also like if there is any kind of a problem, then we might need to roll back the version, right? So with the use of those container platform and with the Kubernetes, we can do those rollouts and the rollbacks very easily. And the next thing is the scaling and the load balancing. uh, uh, because like we don't want a single machine or a single container to be running and serving all of the application, because that could go down at any point in time, right? So we don't have multiple replicas of the services, and that needs to be scaled up. Let's say, for example, if a shopping website might receive a very good amount of traffic on a weekend or maybe on a Friday night, right? And our services which are serving that request should just scale up according to the number of the requests, or according to the queue size, or according to the CPU or the memory uses, and that needs to be load balanced in such a way that the healthy container is receiving the traffic. So these are the things Kubernetes mainly performs. So just a high level of functionalities. And so diving into the GKE platform, so Kubernetes was started in 2015 August, so it has been like 6 years, and uh, on the GKE platform, and before that it was evolved as a Borg, which is an open source platform developed by Google. And after the evolution of the GKE, and with the Kubernetes being way too more popular, and it is a part of the Cloud Native Computing Foundation (CNCF) community, and even in these days, uh, Google engineers or the Google resource has a big number of the resources who are contributing to the Kubernetes, and even the test or even the compiling of the Kubernetes resource is happening on the GKE. So with that being said, we can be confirmed like there are lots of Easter eggs, or there has been lots of tests going on the GKE with the new features as well, and we could be very confident, or like we could at least be assured that the Kubernetes platform, which is compiled for like the different version or the newer version, so that is running on the GKE very too well. And on the recent days, so there is a news like, and they're also being running like lots of thousands of nodes within a single cluster. So that means like you could run very big amount of load for a very high traffic system on the Kubernetes cluster in GKE. So talking about the Kubernetes in production, so one of the utmost thing and the first thing is the cluster setup, because for the new things, setup is always a pain, right? So, and also with the complexity of setting up the cluster and handling the servers lying behind the clusters, those networking stuff, so those takes time and technical expertise also. But with the GKE, the setup has been a lot more easier with just clicks. We can do the cluster setups, and we'll go into the demo also for the cluster setups. And the next part is the security. So there are things which are the security part, which is handled by the cloud provider or the Google, and those are the things that needs to be handled by the application development team or the DevOps, or the off side. So and also for the cost part, so even with the with the new evolution of the news kind of a platform, we cannot go beyond our cost, and we need to minimize the cost and just pay it for what we use and what is required for our services to be running. So that is also the concept of the horizontal auto scaling. So we pay, or we demand only that much of a resource what is needed for us and what is needed for our services, and we ask the cloud provider for providing that resource at any point in time, and this provide us, and we just bill them for only for that the usage time only, and the service deployment, right? So with the evolution of the microservices, there are lots of things to be running, not only the simple deployment, or not only the like the HTTP servers. There could be lots of the jobs running in there. There's lots of cron jobs, so even the stateful set you could be running the database, and there is a complexity in running those deployment. And also for the monitoring part, with the increasing number of the like the servers or nodes or even the services, the monitoring is getting complex, right? And also for the technical expertise we need for managing all of these things. So we'll dive into each of those, how we can actually kill those challenges, or how we can simplify those challenges, and get our cluster ready for production with the best practices in the industry. So if you go into this URL like cares.af, so you will see lots of the failure stories. So let's not be next. So there are lots of interesting stories in this website, so you could go and read, and so that even if you are diving into the Kubernetes, or if you are already using the Kubernetes, there are lots of things we can learn from those failure stories, so that we will be more proactive, right? Okay, so on the cluster creation part, so traditionally we used to like before getting familiar, or even after getting the familiarity with the platform, we go into the web console and we do some like enter some, fill up some form, give few clicks, and then we create the cluster. And the complexity of the Kubernetes, and with the multiple options available in there, we could be using lots of those features, right? But it's hard to track. So if you are, let's say 50, or like let's say even the 20 clicks or 20 different options in there, and if I'm going to create a cluster and I couldn't remember after a month maybe, so what is the option I clicked, what is the version of the cluster that I'm running on, what is the configuration of the cluster we are running on. So to mitigate that, so there is a concept of infrastructure as a core approach, where we treat the cluster or any of those cloud resources as a service, right? So just like how we run our how we create our application in the code, and we just put it on GitHub or Bitbucket or any of those code repositories, we do reviews, right? And then only after the merge we apply those changes, or we release the change. So just by that, way. So we treat infrastructure also as a code so that they will be reusable. So for example, if I am creating a cluster for a dev environment and I want QA or the production cluster ready in, let's say, few days or few hours, then I can just reuse all of those codes which are maintained for the dev environment and just apply the similar kind of configuration with the minor tuning for creating the production ready environment. And that also creates a testable infrastructure. So whatever we could create an environment for a load test or anything, and then we could just replicate that to the production environment, so that we don't have to give a hit and trial on the production environment. So that's the benefit of using the infrastructure as a code. And for that, we have a very good platform, and I like it the most. That is the Terraform, and there is a GCP deployment manager also. But Terraform is way too like very good platform in there. So there are lots of the cloud modules available in there, lots of resources we could create, and it is not only for the Google. So you could create any of those clouds. Let's say that you can create AWS or even the GitHub repos, maybe Bitbucket. Lots of providers are in there, and I'm talking about the Google Container Cluster resource. So by this way, so if you see on the right side, there is we are creating the Google service account, and we are creating the cluster, we are giving the node location, and we are giving the node count. So these are all of the things these are the variables. There are lots of those variables. So if you go into the Terraform resource, or we can also use the interactive tutorial within the learn.hashicorp.com. So the Terraform is a HashiCorp project or the product, and it is available open source, and we could use this open source for creating our cluster and managing all of our cluster resources. So everything which we create on the Google or within the GKE platform, those can be handled within the Terraform course. So we'll also create the cluster using the Terraform and on the manual way as well. So talking about the Kubernetes security, because security is almost like very important part, and because we have lots of services running, lots of complexities, lots of teams might be uses it, and there might be let's say a very secure platform that could be used for the health care or maybe data processing, which is a very secure platform, right? So for that, there are lots of security best practices, and which is to be handled by us as a user as well as the cloud provider. So the cloud provider handles the things like the Kubernetes resource patching. There might be new vulnerabilities coming on the Kubernetes resource, and they do the minor or the major patching, rolling out the different kind of the newer releases. So those are the things, and also the node security. So those are the things that is handled by the cloud provider, but there are few things which is need to be handled by us. So one of the important thing is in the cluster security is the master or the API access, because the Kubernetes is all API driven, and we have an API URL or the API IP address where we call for creating or managing any of those Kubernetes resources. So that is the only endpoint where we interact with our Kubernetes cluster. So that access control also, and also the node securities, because within the cluster there are lots of nodes running, lots of applications that might be running, and we cannot just leave that freely, right? Okay, we need to protect that from the external environment and give access for the specific set of services. Let's say by not using the root account, by not opening like random ports in there, or by giving a specific firewall rules, right? And also for the networking things. So a different VPC is a very good practice within a different subnet, and getting a firewall around them. So that is a very good way of managing the network perimeter. And the API access control. So I already said what are the resources that need to be provided for a specific group of the people, and also the networking limitation of the API URL or the API IP address. And there might be different team using that and different services using the Kubernetes, but we can just give the access which is required for that specific service or a specific set of the users, rather than giving a master control for all of those users who doesn't require, right? So that is the part of the cluster security. And the application security part, so we are running containers, the Docker containers running, and at least we need to have that container secured and with a very least privilege. So for that, one of the important thing is the container or the base image security itself, because there might be lots of patches, lots of vulnerability even within the container. Let's say, for example, if you're using Ubuntu or some Alpine image which was 5 or 6 months old, then and if you do the scanning of those older images, then new vulnerabilities may have been found, right? And there might be the packages, or there might be some of the repositories which are not required for us within those images, and that needs to be removed. So those kind of vulnerability scanning and those uh, vulnerability exploration is provided by the Google itself, and also the code and the dependencies, because if we have a wrong code in there and the wrong dependencies or wrong modules which are used by the code, then whatever the security of the cluster, that is a high chance that the resource is being compromised. So one of the important feature within the ZK is the private cluster. So that means our cluster is fully isolated from the public environment. No one from the public environment is able to access. So only the resource is accessible from the URL or from the load balancer side, which has a very specific port open for the public environment or for the public users. And all of our environment, all of our resource within the cluster is fully isolated. That means that is not being accessed for the public, and the cluster could not be able to access the public resource randomly. So for the public cluster access, so there are different options for creating a private cluster, where we can just protect our cluster from reaching the public internet. That means our cluster is fully using the internal resource and within the perimeter of ourselves. And even like we could configure the cluster to use only the Google resource. Let's say, for example, if we want our internal Docker image to be used but not from the Docker official registry, then we can use that. So only using the internal resource. Let's say, for example, if we are doing a data processing, I don't think that will need like the external things, right? So the benefit of having a private cluster is, if something happens, if we are gonna compromise, then there is no way for getting those traffic outside of our perimeter, and even for getting inside the cluster. So that provides a lot more security. So this is one of the important things that needs to be considered while creating a production level cluster. And there might be cases like we need to access the external resource or maybe call the external API, and we can do that with the NAT gateway, so that we have a specific set of IP address which will call to the external URL, and we could configure the firewall for controlling those egress traffic, and also limiting the control access plane. That means the API access control. And within the cluster access control, so we might have the different kind of clusters. Let's say the dev and the production cluster, and everybody doesn't need the access for the production cluster within any level, right? So we could use the URL, maybe like the email address or the Google Cloud account for our company people, or let's say for a developer or the engineering team, and we could give the specific set of the roles. So for example, we have the container admin role for the operations team, and for the security roles, we have just the container viewer and the security admin, right? And for the networking, they just need the network admin access, and for the deployer, so we just need the container deployer access. So by using this kind of a granular access control, we could keep a better track of who is accessing what of the resource, and uh, someone couldn't do like accidentally delete or accidentally change any of those configuration within our cluster. Okay, so we talked about having giving people access, right? But there is a different level of access also for the services which are running inside the Kubernetes cluster, right? So say, for example, we have on the cluster A, we have the namespace backend, right? And we might be running a payment service, right? And we might be using the KMS keys from the Google, like the security encrypted keys on the Google. And we just don't want to give access for the KMS keys for whole cluster, but we want to give the KMS key decryption or the encryption access to the specific payment service within the backend namespace. right? So for that, we could just use or integrate the Google service account by using the workload identity, so that we create a service account where we give the decrypt access for the specific service or maybe the payment service, and only the payment service within the backend namespace within cluster A and the cluster B could decrypt the KMS keys. So these are the levels of the access we could give for both the people as well as the environment or the services which are running within our cluster. So I already talked about the container security. So by using the Google Cloud Build, which has a very good integration with the vulnerability scanning out of the box. So let's say, for example, you have a code on GitHub or Bitbucket. So there is a direct integration of the code build with Bitbucket GitHub, right? So whenever there is let's say we have a new tag created or there is a merge on a new branch, so then the code build is triggered and it will create the image and the GCR vulnerability scanning, so that will scan the image for checking like if there is any kind of the vulnerable things inside the container, right? So that could be of the lower or the higher or the medium level of the vulnerabilities, and by checking the vulnerabilities level within the container, we can check like whether that needs to be running on the production or not, or what are the actions we need to do for managing or for removing those vulnerabilities for the container which could be running on our GKE. And with the concept of the binary authorization, we could give like let's say our container could run on the GKE platform on the production cluster only if the QA people authorize it. Let's say, for example, if they are testing something on the QA, and if the image is trusted by them, or if the deployment is let's say um, trusted by the QA team, then only that kind of image could run on the GKE platform, nothing other than that. So if there is a compromise or if somebody wants to do a faster release by avoiding this type of the rules, then that won't run on the GKE. That will be completely neglected by the GKE platform. Even they try to run, that container will just not run, or maybe go into the crash loop, or that would throw a different kind of error, but at least not run. So these are the kind of the privilege the GKE provides out of the box for the container scanning and for giving the access to the specific container that is to be running on the GKE. So if you go into this repo, so this is like a very good repo maintained by the Google Cloud Platform on the GitHub GKE Cloud Security scenarios. So you could get more on the security best practices and within the examples as well for keeping our applications secure. So talking about the availability, because when we talk about the Kubernetes, we always talk about the availability and the scaling, and we might have applications running or that is to be used by a global set of the users, and we don't want to be that like loading way too slow, and we have to have a very small latency from the end users to the load balancer or to the cluster, right? So based on that need, we can have a different kind of a cluster, like the zonal cluster, multi-zonal cluster, or the regional cluster. So with the zonal and the multi-zonal cluster, there is only specific one master running on a specific set of the zone. So from the DR perspective, we could take in that. And for the regional cluster, and we could just run the three cluster resource or three master on three different zones. So let's say, for example, A region goes down and there is B and the C region, then with the multi-zonal or the zonal cluster, that cluster could go down. But with the regional cluster, that cluster will be running very seamlessly. And also there is a different SLA for that. Like there is a big difference between the SLA for the region and the multi-zonal resource, but at least this comes within the cost, right? So we need to calculate the cost, we need to calculate our DR plan, what is the RTO, RPO for that, and we could choose any of these options. And the next thing is the load balancer. So on the GKE platform, the load balancer facilities or the services provided by the load balancer is increasing and getting too much beautiful as well. So currently it has a fully managed SSL certificate, so we don't need to care about the SSL certificate. It's completely free and it can be integrated with the load balancer. And so the flow goes like if we have some service running on the URL and that is behind the load balancer, we could configure like we want a full SSL redirection for that. And if we have static codes running in there, sorry, the static files running in there, let's say the images or video that are stored on the cloud storage for the specific path of the load balancer, then we can configure that through the load balancer as well. And the identity aware proxy, so this is like way too beautiful. So for example, if you have some internal application which needs to be accessed by the specific set of the users internally, then we could integrate the IAP on the load balancer, so that let's say if I have a company named ABC and all of them having a Google account, right? And then we can configure the load balancer so that only the users who has the access to the email, or who has the Google account, and within the access of the Google Cloud Identity Access Management, then only those users could access the load balancer resources. And also there are lots of things like the timeouts. We will configure the draining timeouts, SSL redirection, and the health checks and the monitoring for the load balancer, like what is the latency with that, what is the error rate, what is the like the return code or the status code. So those are the things that could be monitored by the load balancer. And next thing is reliability, because with the increasing number of the services, increasing number of the complexity, lots of URLs, lots of services running in there, and with the different types of the services, we need to have a reliability among those services. And the reliability also depends on the type of services we are running. Sometimes there might be the latencies, and sometimes there will be let's say the complexity within some jobs. So there are different kinds of reliability, right? So for that also, so even for the reliability in our applications which are running into the Kubernetes cluster, so we need to have some scaling to mitigate the reliability, or to achieve a specific state of reliability, right? So let's say, for example, if we have Friday night and we have a shopping store which gets lots of resources, and that needs to scale at a specific point in time when the lots of user comes in there, right? So we cannot go downtime when the user exceeds from, let's say, 100 to 1000. But our resources or our Docker containers which are running on the Kubernetes platform, that needs to be scaled up. So that is the horizontal auto scaling. SPA means horizontal pod auto scaling. So that means if we have 100 containers running for the auth service or for the API, that could scale up to, let's say, 500, or let's say to the 1000, based on the resource demanded. And the BPA, the partial pod auto scaling. So this is a new concept where the auto scaling is handled by the Kubernetes cluster itself, and this is inbuilt in the GKE platform. So this auto tunes the resources that is used by the pods, so that we don't need to care much about what is the specific state of a resource we want to give for the specific container. It will auto tune based on the its own AI, or based on its own platform. So it calculates the average usage of the CPU or the memory, or any of those disk IOPS inside that, and just tunes in them. And the pod disruption budget. So this is very interesting thing, and this needs to be have been there on the production cluster while creating a production cluster, right? So this is for, like, let's say if we might need to do some rollouts, right? Even for the application rollout and even for the cluster rollout, we might need to upgrade the version of our cluster. We might need some maintenance in there, but we don't want our service to be affected by that. So, for example, let's say we have a newer cluster version coming in, and we need to delete the older nodes with the older version, and we need to roll out a newer nodes in our cluster, right? And we have, so in this example, we have Zookeeper running in there with the max on available of 1 and the minimum available is 2. That means even if the nodes are going to be rolling out for rolling the newer version, our Zookeeper containers that is to be running, that should always be at least 2 containers of the Zookeepers running in there. So if this is not gonna be respected, then I just want to terminate, or maybe I will just pause the rollout. Because if the Zookeeper goes down, or if there is at least not 2 containers of the Zookeeper running in there, then my business is, or maybe my service is gonna be affected. So I don't want that, right? So these are the kinds of a rule we need to set up by while doing the production deployment, or while doing the production rollout, so that we could always be sure, like, at least this number of container is running, whatever be the reason. And the important feature of the GKE, which is very useful for any of the cluster, like the production or the dev or any of those things, is the upgrades and the patches and updates of the cluster. So GKE provides a regular patch and updates of the cluster, and we, while creating the cluster as well, we could configure like whether the upgrades has to be rolled out automatically, or we just roll out manually for this cluster, and those nodes are going to be roll out on a rolling fashion. So there's not the case like delete all the nodes and just create a newer nodes. That will cause the downtime, right? And what is the number of the nodes that is going to be down at a specific point in time when there is the upgrades and the newer nodes is going to be replaced, right? And this interesting concept of a maintenance period. So for example, if we have very low traffic at tonight, or maybe night 1 a.m. or something like that, or maybe on a Saturday night, so we could configure the maintenance window based on that, and at that window or within that maintenance period only window only, GK will roll out the newer version, so that our workload is very much less affected. And there might be cases like we might have thousands of node running in there, and we might give the maintenance window time of only 2 hours, and that might not be possible, right? We might not, GK might not replace thousands of node within the 2 hour. So in that case, GK will stop after the 2 hours and will stop the maintenance or stop the rollout. So that means like the updates or the upgrades are within our control, right? So none of the resources are going to be affected after the maintenance window, and after, let's say, tomorrow 1 a.m. or the tomorrow 12 night, that maintenance window will be started again. And the next thing is the maintenance window, do not disturb mode. So if we have configured a Saturday night maintenance window, and let's say, for example, there is Jan 1st, New Year Day on the Saturday, and what is going to be done? Like, we might get lots of things, right? So we can configure the do not disturb mode for the maintenance, and at that specific point in time, the maintenance will not happen, even that is within the maintenance window. So this is like way too interesting while doing the rollouts. And then networking policies. So we talked about the giving the access for the people and for the resources to execute or to access the Google resource, but even from the networking perspective, right? So let's consider a e-commerce platform where we have API, where we have auth or the payment service or the product service, and the payment service might need extra security, right? So we might not want to give the payment direct access from the API, right? Or maybe we want the payment service to be accessed only from the product service. So these are the kind of rules we can apply on the Kubernetes policies, so that a specific set of a service or specific containers within that service can call the another service. So we could be very restrictive in this fashion. So here in this case, only the app equals web. That means maybe the API or the web is going to be accessed from the external traffic, but no one is going to access the foo and the bar. But only the app equals web can access the app, foo, and the bar. So we can be very restrictive based on namespace as well. So even on the production cluster, we might have the stateful services, maybe the database running in there, and another set have API running in there, and another set of services have some specific or maybe the very secured healthcare related services or the payment services running on a different namespace, right? But so with these network policies, we can control the traffic flow between those services, between those namespace, and allow only the specific set of the services could be accessing the another set of the services based on the selector or the label, right? Okay, and the multi-cluster things. So we talked about the regional and the zonal cluster, but here is another interesting concept which is available on the GKE, and this is very useful for the production if you are running very critical application or that needs very high availability. So I was thinking about one specific case. So we want to have our stateful sets, maybe the database or zookeeper of Kafka running on a specific or a new cluster, on a dedicated cluster, and that has some extra security in there. And we don't want to mix up that cluster with external application, right? So we can configure that way. So like database or the stateful resources running on one cluster, and maybe the web resources running on another cluster, and that could communicate within those two clusters internally, and those using the single load balancer as well. So we should create a lot of shareable resource within two or multiple clusters and just access those resources internally, and using a single load balancer which has a multi cluster capability. And the service mesh. So Istio, I always remember about the Istio when we talk about the service mesh, right? So this is also provided by the GKE inbuilt or out of the box as well, right? So when we are creating the cluster, we'll see in a while in a demo. So we can just select few of the options while creating the cluster, and that will have the Istio installed in them. So we don't need to worry about the Istio control plane. So we can just run our multiple like microservices, which needs high visibility of each of the resources or each of the traffic flowing between them. Now we want to control or maybe apply a very advanced application modernization rules. Let's say the traffic mirroring, or we want to have a canary release. We want to control the traffic based on specific headers or the specific tokens, or we want to have different types of authentication mechanism for accessing the service, and those all being inside the TLS communication, so that even within the cluster we can have very secure communication between the services. So this is like, so if we are using a multi like the microservices model, and there is going to be lots of the internal traffic exchange between the services. So I will highly recommend to go through the service mesh concept or STO. So it is uh, one of a very popular service mesh platform, which is Google also has a very huge contribution on making the service mesh STO. So even for the visibility, like the monitoring matrix, it has an inbuilt Prometheus inside it, so that all of the traces of all of the requests going through each of the resource is tracked very beautifully. So when we talk about the running lots of services inside the cluster, and there might be problem within the cluster, like that. There might be problem within the services. There might be problem on endpoint. There might be problem on a specific resource or a specific tasks or a specific events. So we cannot go and scroll through monitors whole day or 24 hours, right? But at least we need some alerting mechanism. We need the logging of the application. We can monitor the applications within the platform, so that if there is some anomaly happening within the cluster or within the services, then we need to be alerted. Or we can set a very good SRE platform or a SRE way of managing or viewing those services by setting the SLO and the SLI for the specific state of the services, right? So these are the things that is provided by the Cloud Operations Suite, and this is fully integrated with the GKE. So any service we run on the GKE platform, so that will be accessible, or those can be monitored within the Cloud Operations Suite, including like the logs, the metrics. We can say the alerts based on the metrics. That could be latency, error rate, number of restart of the container, number of the error rates, right? And even the custom attributes, we can set that on the logging, and those can be tracked with the monitoring and alerting through, let's say, the alert management thing. That could be Slack or uh, those kind of incident management platforms in there. And we could have a beautiful chart for the specific services or specific users. So let's say, for example, the product team might need a chart of the visibility, where what is the performance of the product service, or what is the metrics of the product service happening in there, and if there is a degradation of the service, and we need to be alerted. So these are the integrations that comes under the GKE. And the application lifecycle management, so this is always the complex. If we have like one or two, maybe five services, that could be handled, But if we have a growing number of services, we need to have a specific mechanism, or we need a way of handling those services, so that there might be the newer releases, there might be new variables, there might be new attributes to be added on those services or those containers running inside the Kubernetes. So this becomes like way too complex if we are going through like managing those Kubernetes resource with a simple YAML file. But we have the Helm. So this is a version 3 that is being running recently, and it is a very good open source platform with lots of contributions from lots of people, lots of cloud communities. So this simplifies the way of handling those applications. So that could be for the rollout, that could be for the rollback, right? That could be for the environment variable management, that could be for the network policies we talked about, right? That could be for those port disruption borders. So anything which is written on the Kubernetes YAML file or those manifest file for defining those resources. So that could be managed through the Helm and within a very good version control system. So it manages all of those templates of the Kubernetes in a very modular fashion within the concept of the versioning, right? So just like the Terraform we talked about earlier, so we could have a very we could have with the version control, the review system in the chart, and what is the version that is being rolling out, what is the exact configuration of our services that we been rolling out, and also this provides us a package. So that means if we are running a service on our dev environment and we want that service to be running on our production environment, right? So on the dev environment, we might have lots of resources attached with that specific service, and we want the replica of that on the production. So within the Helm, so there is the concept of the Helm chart in there, which is the like bundling of all of those Kubernetes resources. We'll see in the demo as also in a while. So we can just share this chart, this Helm chart, with the production team, and they can just run that by using those chart. So that makes it a lot more easier. And the access of the Helm is just like the kubectl, the binary we use for managing those Kubernetes resources. So these are the things, and we'll go into the autopilot in a while. So before that, so let's just go into like creating the cluster with these things we talked about, right? So I'm on the GKE platform, right? So there's the thing like the GKE standard and the autopilot. So we'll dive into the autopilot in a while. So we'll just go into the GKE standard. So we can do the comparison as well. So I will go into the GKE standard. So we are just going to the web way, right? So this is not a good practice for the production, so we'll go into another infrastructure as a code approach with the Terraform in a while. But let's just explore for creating the cluster by this web way. So there are the different sets of the guides as well. So if you are doing the experiment, just roll out this small cluster, or if you want a very cost optimized cluster, go for it. It has a very good template in there. So the first thing is we want to give our first cluster. So I'll just give GDG Cloud KL demo cluster, and we want to be a zonal or the regional. So if you want to make it a zonal, we can give it a specific zone where we want to run our master. So I'll just select 1B, or we can have multiple nodes running. So that means the US Central 1B will have the master of the Kubernetes, and these multiple zones will have the nodes running in there. So I just go and select the regional cluster, and so I want it to running on US Central 1, and the node location I want to be on A, B, and C. So that makes our cluster highly available with a very good SLA as well, right? So and the next part is the node. So what are the types of a node we want to provision? So this is the major resource where our application runs. So what is the type of the nodes we want to run on? So if we are running uh, if we want to run application which is very good, or which is very hungry on the CPU, so we can just, so the CPU intensive like the 8 core 32 GB, or any of these things. I'll just make it minimal. And what is the type of the disks we want to choose, standard or SSD or balanced persistent, so we can choose that. And the size of the boot disk, so I just give it a minimal for now because we don't need bigger one for the testing. And for the security, so we can manage the encryption of a disk also. So if I want the disks or the nodes to be encrypted by my own key so that even Google cannot access the resource, then I could do that. So I just leave it disabled for now. But for the production, this is a very good practice. And on the security part, so what is the access do we want to give for the node, right? So now let's say if we give the access to the node, then that access will be obtained by the pods as well. So for the default, or for maybe for the dev or the product, like the testing environment, this default might be good, but we don't want that. So we want to be aware of what is the specific state of the access we are going to be giving. So by default, this has the cloud storage read only, but we don't need it, right? So we can give it to none because we want our production cluster to be very minimal and be accessing only the required resource. We want the logging to be enabled so that all of the logs are sent to the stack driver, and the monitoring as well. So rest of the things should be good, right? And the secure boot as well, if we want to be with a very good malware protection system. And metadata, we can give few of the keys, instance keys, or if we want to give some extra level, maybe the environment production, so we can give it. And for the automation part, so if we want vertical auto scaling, so we talked about the VPA or the horizontal auto scaling, right? So we could enable the VPA also so that we could use this resource. And on the networking side, so there is the option of a public and the private cluster. So the public cluster means the API or the control plane access is given, or the URL is exposed to the public world, but we don't want that, and we want to create a private cluster, right? So within the private cluster, so what is the control plane? So if we want to give the control plane global access or not, and what is the control plane IP? So I will just use this default one. I don't think this is being used. Okay. And the next thing is, what is the IP address? So I'm not going through like each of these options, but the major options. So for the control plane, so this gives us the ability to choose which network we want to give the Kubernetes API access. So for example, if I want my local system to be accessing this Kubernetes cluster, so then I could add my own local URL. So I'm doing this uh, by giving my office IP. Let me check my office IP. So this is the IP. So because I for this demo, I just want to access the resource from my local. Okay, and then done. And for the extra security, so do you want to enable the binary authorization so that only the whitelisted or only the authorized container could run in our cluster, nothing could run. And yeah, and the workload identity. So for example, if we want some sort of a service to be accessing the KMS or the Google Cloud Storage, then we need to enable this workload identity, right? So that we don't need to provide a specific service account or the service account key for that access. I think for default, I'll just keep it as it is, and we can enable the Istio as well. So that the Istio control plane is managed by the GKE itself. We don't need to install the Istio. So I'm just leaving it as default and creating the cluster. So we check lots of options, right? Okay. So there is a quota in my account. So I'm gonna choose a very small node instead of a CPU. Okay, so this should be good. Okay, let me create it. So for creating this cluster, we choose lots of those options, right? So even if I try to create a new cluster again, so I'm not sure like I will get to this exact state, because there are lots of options and we might get lost. So that's where the concept of the infrastructure as a code arrives. So for that, I'm gonna go through this Terraform. So I'm using this module called GKE cluster, right? This is from the groundwork, so I'm optimizing using this as an optimized cluster. So here we are using the module and we are giving few names like the what is the name of the cluster, what is the name of the project we want to run, what is the location, right? What is the network we want to run on, and what is the sub network. So these are the things like the node pool. Okay, I don't see my screen. I think my screen is lagging a bit on there. Okay. So within the Terraform, so we can give like different variables. What is the cluster name? What is the networking parameter we want to define? What is the auto scaling things? What is the node resource like? So even like while creating the cluster, I earlier gave a very high CPU node, but now I gave it with just 1 core and 2 GB of the memory CPU node. So those are the things that is to be configured. If we configure that from the Terraform, that is way more easier. I'm not seeing my another screen. Uh, Let me just stop my share and share it again. Let me share my screen. Okay. Okay. So it's there. Okay, so with the Terraform, we can define all of those rules, like all of those things which we did manually from the Terraform, right? So we can just give the like the cluster name in here with the name variable. What is the project name we want to give? What is the sub network we want to give on, right? What is the node pool? Like I want to have one single node and it will scale up to 5, right? So these are the configuration with like what is the service account, what is the access do we want to give, what is the scope we want to give for the cluster. So these are the things we can configure from here so that it is under a total version control. So for example, here is the disk space of 30 GB, or and again let's say for example we want to change it to the 50 GB, right? And if I do change from the UI itself, then we could lose the track of what is the exact state of our cluster. But if we do it from the Terraform, then we have the idea of exact state of the cluster, exact version, exact configuration of the cluster, right? So for using this, so I'm just going to use, this is the Terraform binary. So you could download Terraform from Corp site. So this is just a simple binary, and we can just do Terraform apply. So Terraform apply means, so all of these definitions of the clusters and these things, so this is going to be created on our Google account. So it is asking for the location. So I just give US Central 1. I just give, let's say 1B. I'm just giving a project ID. And what is the region? It is US Central 1. So it is creating all of the resources, even the cluster service account, which we just did by the UI. So for the production, it is a very good practice to use this kind of infrastructure as a code approach, so that it says like there are 16 resources to be added, nothing to be changed, nothing to be destroyed, and we can see like this green icon means this resource is gonna be created. So that means the firewall is gonna be created. We have the another firewall that is being created for protecting our, like for the private allow only invest rule, and we're gonna create let's say the sub network is gonna be created, right? So we don't need to go through each of those UI components or on the firewall or the sub network UI, but we can just define it in here and create that. So it is asking, do you want to create it? Yes. So for example, like let's say if I'm creating this dev cluster and I want to create a production cluster, then I can just create a replica of these cores and I can just create a production cluster so that I could be very confident on the production, uh, like any of our services, any of our load balancer or those things we're running within this cluster. That means that works well on our production cluster as well. So for the case of the testability, so this is a very good resource, a very good platform. Okay, let it be created. I think that will take some time. So if we do refresh, okay, so this is created, right? So I just connect to it. Sorry, so I could just click on connect and I could get the kubeconfig file. That means the authentication for that. So I just type it in here. Okay, and this is my kubectl binary. So this is still on the processing, maybe with the networking things. Okay, so we have no resources in there, right? So let's dive into the application, and I'm gonna in this demo. So I'm gonna be using my specific this repository. So where I have, so I'm just creating a flow for the application deployment. So we have the API auth and the product service in here, and for the build, I mean for the Docker container build, I've set up a cloud build YAML also. So that means whenever I create a new tag on this repository, so it will create a new Docker image with this URL, like the GCRIO, my project name, GDG Cloud demo, and auth, and my tag name, right? So if I create a new tag, let's say I want to create a new tag from the master branch, and it's always a good practice to use a tag rather than using the master branch, because using the tag makes it a lot more easier when we want to do rollback. So I'm gonna create a new tag. This will be, let's say, 1.0.0. Oh, my UI is loading way too slow. Okay, let's try to reload it one once. Okay, 1.0.0 live on demo. I just published this release, and it has a pipeline with the cloud build, so that if I create a new tag, that tag will trigger the cloud build, and a new Docker image is created for all of those three services. Search for build. Okay, we have code build in here. And we should also like while creating the and after the Docker container is created, then that should also do the scanning, like whether there are vulnerabilities in the Docker containers or not. And that is also out of the box feature. Okay, my UI is loading way too slow, maybe because I'm using an external monitor. Okay, let's go into the cloud build. So where we can see whether the build is succeeded or not, and what is the tag version of the build, what is the version of the build. So all of those things can be seen from the cloud build. Okay, so on the history section, so the tag we just created was version 1.0.0. So this should have the history or the trigger from the GitHub, because we have configured the GitHub to use cloud build whenever there is any tag is created on that specific repository. Uh, it's like a stock. Okay. Maybe my internet connection. Sorry. Okay, play around with live demo. Okay, so we can also add a new trigger. Let's say if we have a new repositories, and in most of the cases, like there might be a different repository for the different services. So, and we can set a trigger for those different repos from here, and we can say like whether there is any commit on any of those brands or on the master brands or any tag is created, then just trigger the code build to create a new build or the new Docker build, or any of those steps uh, which is defined on the cloud build.yaml file. So just like this one. So this is the format of the cloud build. Let's give it a sec. Okay. So the same format as the cloud build, and we could write any of those steps within the cloud build.yaml, and it will be taken by the cloud build service. Oh, what is happening? This is not loading at all. Okay, let it be loading. So we will go into the Helm chart of the like how do we manage the application lifecycle of a service, right? So here for the service, I just use a simple Golang application like the GDG Cloud demo, and welcome to our awesome app, and similar for the auth and the product service. But the difference is like I've used Golang 1.7 here, and on the auth service I've used DistroLess, which is way too secure. So we'll see from the vulnerability scanning report, like what are the vulnerabilities that it shows on the Golang 1.7 and on the auth DistroLess. That's the reason for using the secure image. Okay. Okay, so yeah, so we have version 1.0.0 created in there, which is created. So it took 1 minute 12 seconds, and if we go into the build history, so we'll see all of those three Docker images are pushed because we have written the same on the cloud build YAML Docker push and the image which is built on within this step. So same for auth, product, and the API. So all of these three services should be pushed, right? So the demo auth, product, and the API are there. Okay, so let's go into the vulnerability report. So the Docker images are stored on the cloud registry. So we go into the Docker registry, and we can see the vulnerability scanning in there. So the container registry. I don't know like why this UI is loading way too slow. Giving some passes. Okay, so yeah, so we have the GDG KL demo repository in there. Okay, so let's see. So the API, product, and the auth. So there is a difference, right? So all of those were created within the 6 minutes ago, and one is 333 MB, one is 5.9 MB, and another is 11 MB. And for this API, there are 168 vulnerabilities found, though we are using the official base image of the Golang, right? So let's see what are the vulnerabilities in there. So there are 168 total, with higher vulnerabilities of 5, 15 medium, and maybe lower vulnerabilities. So even like the critical vulnerabilities are there, right? So you can go into the CVE link and maybe upgrade or maybe remove those kind of the packages. So for the another service, so for the API there were lots, right? And the size was also big, but the product doesn't have the vulnerabilities as at all, right? None is found for the product. So the reason is, for the API I use the base image Golang 1.7, and it created a big 300 MB of the image. And for the auth, right, and for the product as well, so I just use Alpine, right? So by using these minimal images, the vulnerability count is going way too low. So it's a very good practice to use a very limited or very minimal image what is required, rather than using a whole bunch of Golang or another big bulk of image which has a very good chance of having those vulnerabilities. So we need to be very special careful while creating the deployment with these images on production environment. And by going through these vulnerabilities, we can be assured also, right? So coming to the application lifecycle management, because we might be running out of time as well. So we have the chart of the API and the auth service in here. So this is the Helm chart. So if you go into the Helm chart of the API, so we have the chart section, and this is just the we can store the archive or something, and we have the inside the templates we have the different definition of the resources, right? So we have the deployment. So this is just similar like the Kubernetes deployment. If you are saying like what is the container we want to run, what is the image version we want to run, what is the port that is being exposed, what is the liveness, like how we are checking the readiness or the liveness or the health check of that application. And also like if we want there to be the HTTPS redirection from the HTTP, and what is the ingress rule we are going to be defined, like what is the SPA, what is the pod auto scaling limit we are going to be setting. So these are the rules which can be managed for the API service or for any of those service. And the beauty is, so if we are running this API right now for the dev environment, and if you want to run that application, this same application for the production environment, so we can reuse this cert for the production, because we have lots of those definition already written in there, except for those which can be changed in these values.yaml file. So here we can give like what is the tag we want to give for this GDG KL demo repository, right? And what is it, like if you want to create a service account, what is the load balancer, what is the URL of the service, right? What is the static IP we are giving, what is the timer. So these are the variables that could be changed, but within these templates we can reuse all of these templates file for the production also, right? So let's try to install and let's see how easy it is. So I'm going to do helm ls. So helm is the binary file. That's a binary file, no extra installation required, and we could install with helm install. I want to give a cert name, which is the API, and let's give helm API. By just entering this command, it creates lots of resources, right? So lots of these resources, including the deployment, backend config, and the network policies, whether we want to give the ingress and the egress rule. So these are controlled from the network policies we talked, right? So this is installed. So if we check kubectl get pods, so let's check we have pods running. So it is being created, and this is not ready yet. Okay, we set it to 2, so it is being created. So after this is being created, and we have configured it to use or create a certificate also, the managed certificate from the Google, right? And we give the URL of demo-api.this URL, right? So within a few minutes, we should have a fully HTTPS URL, which could just send the traffic to the API service. So this is like a way to simplify creating the service. And we just install the auth service, just like Helm install auth with Helm chart link and auth. So this will install the auth service, right? So this makes it very easier for the application lifecycle management, right? So if we check the version, let's say for example, we had the version 0.0.3, but we just trigger 1.0.0, and we want it to deploy to the 1.0.0, right? So you could have that maybe any other deployment platform. You could use Jenkins or even the Cloud Build or Spinnaker. So you could use lots of those deployment platform for creating this kind of a deployment. So the process is, let's say if I want to upgrade the API, then I just do Helm upgrade. I want to do API upgrade and Helm slash API, right? So this will create a new version of the API, because we just changed from 0.0.3 to our newer version 0.0.1. Okay, so this is upgraded, and if we do kubectl get pulse, okay, the container is being created and the old one is still running. So after the health check is passed for the API of the newer container, then we have this old one just being removed from our system. Okay, so next thing is, if it is running fine, it will take around 5 minutes maybe for rolling out the SSL certificate and getting the load balancer ready. So check. Okay, so this is already up. So this is just our API running in there. So we have to fully manage HTTPS, because I pointed this URL to our static IP address, which is used by our load balancer. So it is a way to straightforward. So we have our application running on GKE on a private cluster. So this is the way we can manage the application lifecycle with the Helm. Okay, coming to our slide. So we created lots of these resources manually and within the Terraform also, right? But if we are going to start the GKE platform, that might take some time, that might take some resource into the learning as well. So to mitigate that, so the GKE Autopilot is introduced by the Google, right? So with this Autopilot, so we don't need to care more about like how our resources, how our containers is going to be running, what is the type of node we are going to be provisioning, what are the resource that is being requested by those services. So it's just like we create the Kubernetes cluster, and the ZK is will be maintaining all of these, like the control plane nodes will be running or maintained by the Google, or even the user pod is maintained by the Google, and only the resources like the networking things and the persistent disks, load balancer. So these are the things that is managed by us, and the cluster creation is way too easy here. So let's do a quick uh, one over there. So if you are starting on the ZK, and you could run it on the production as well, because with this you can just mitigate the downtime. It is kind of like bit of costly because lots of things are handled by the GKE for the autopilot, but it's still the cost of creation and running the application is a lot more easier with the autopilot. Okay, my UI is going crazy. Okay. Okay, I'm going into the Kubernetes engine, and let's just create an autopilot cluster in just 1 minute. I've not been using this external monitor since long time. Maybe that's the reason it's getting way too slow on the laptop. Okay. Okay, so we can just create a autopilot cluster in just a few minutes, and we could run our application in there. Okay, this autopilot. So all the nodes, all of the pods are handled by the Google itself. So we completely don't need to worry about. Okay, close this. Okay, so what is the reason we want to choose? We want to run a private cluster. What is the networking option we want to give, right? Enable, just like we did, like what is the IP address we want to give for authorizing those control plane access. And if you want to create a private cluster, or we just create a public cluster. And there is anything on the advanced section, nothing more important, so we can just create the cluster. So that's it. So it will create a new cluster, and after we try to run our services in there, it will provision the node and it will run and handle by itself. So completely no worries about how we are gonna create a cluster and those things. So it is also better for the learning purpose and for the starting of the cluster. Okay, and that's it. Thank you for listening, and thank you for going through all of these demos. So I'll be uploading all of these resources like the Helm chart, this Docker, and the Terraform into my repository. I'll be sharing this on my Twitter. So I'll be sharing this on my repository. Okay, at least I will be sharing along with this slide for the repositories for all of these resources. Yeah, and thank you again for being with this demo.
Thanks a lot, Raju. I think that would be great that that you're sharing with us the slides, and I think that would be an amazing opportunity for our audience to even get their hands dirty. So once again, thank you, Raju, for the amazing talk and the demo. I think it was a great walkthrough of the planning and operations process. I mean, now that you've explained the important aspects such as whether it's scaling, security, deployment, or monitoring, I'm sure it would be a great help for those who are interested in deploying a production-ready application to the Kubernetes cluster. So before we end our session today, let's move on to our Q&A session. There are a couple of questions from the audience. So would you be okay with taking some of the questions?
No.
Okay, sure. Yeah, so this is the first question that we have. What's the use of headless service in Kubernetes?
So headless is used for mostly for the database stuffs, right? So for example, if you are running MySQL or let's say the Elasticsearch, I will especially take the example of the MySQL server, like MySQL service, where let's say, for example, if we are running multiple pods or the multiple containers of the specific, like let's say the database, and if we are going or maybe requesting to the multiple containers of the MySQL service, then that might cause problem. Like some container might be writing, some might be reading, and there might be like an explosion, right? So for the headless service, it will route the traffic to the specific state of the pod so that there will not be the conflict, and it just go like seamlessly for let's say it is mostly used for the like master slave or some kind of a distributed non-distributed system where we want a specific set of the container or a specific set of the IP could get specific kind of a request, and other could get like handle the rest of the resources behind the scene or behind the main container.
All right. Thanks, Raju, for answering that. We have another question, also from Katie.
Also, when should I use Helm and when it is not suitable to use? Okay, so Helm is mostly as a part of the infrastructure, partly as an infrastructure as a code also. So if you are starting to use Kubernetes service, and if you have, let's say, within let's say 50 or 100 of the services, or maybe like lots of those services, you could use Helm from the starting and to the process of getting it way more complex also, because it makes like you could get the contribution from the development team as well. So you could ask the development team to raise a PR if there is any change that needs to be tuned based on the change of the application. So you could get more collaboration in a DevOps fashion as well. So this makes like Helm to be useful from both the ops and the dev side of the ecosystem. And the next option I see is like if you have way more like bigger application which needs to be visual for the from the UI, or maybe there are lots of deployment patterns you are using, then the another option is Spinnaker, I would say. It is a bit of heavyweight. I think it is started by the Netflix. So if you are going mostly through the UI, or maybe the product or the QA team, which are not too much technical, want to make the deployment and view all of those resources, then Spinnaker is one of the option. So other than that, I would suggest Helm, to use Helm if you, even if you are starting on the mid or even at the production deployment. Yeah, I would say just go for it, and if it starts getting complex, just try to manage with the lesser number of stars, or maybe reuse the stars, so that if you don't have to create a new chart for each of the service, use some more templatized mechanism for that, and it will just be way more good for maintaining those services.
All right. Thanks, Roger, for answering that. Katie, I hope that answers your question. So I think that's about it for today. Raju, before we end our session today, is there anything else you would like to share with the audience?
I'd say like the Kubernetes platform. So if you are okay, I think we have
Oh, yeah, we have
another
another
question.
question.
Is we can deploy any programming language, Java, Node.js in GKE? Yeah, absolutely. So you can just deploy any language, no restriction. You can deploy .NET, Node, Java, Go REST, anything, because anything which you can package inside the Docker or inside the container, that can run on the GKE. And I don't think like there is like in this newer world there is no language which cannot run on the Docker. Or if you can run on Linux, you can run it on Docker. I could say that with full confirmation. So any language, any kind of a services, gRPC, HTTP, any services can run on GKE.
All
Okay,
right.
so on a final note, I would say if you are interested, maybe if you are on a development team or anything on the engineering things, it's a very good platform, or it's very good to know about the Google, or maybe I would say the Kubernetes platform, and you could run it on a local in your local system as well. So just go for it, test it, because you'll get a new test, and it also provides a way how you could manage your applications in the newer world, on the modernized world, and how much of the like modernization things you could get into it. So that I think like even before few years that would have been way beyond our imagination, but that is being handled by the Kubernetes, and that will go on changing. So just go for it, and there are lots of fewer like open source and free resources as well. So I would name it one, the katakoda.com, KATA KODA.com, I think. So that would provide a free resource and a free playground as well. You could create your Kubernetes cluster in there, install the service as we did now, and just use the actual playground in there. And also you could install the Kubernetes on a local with the K3s. So you could just Google K3s. So with that K3s, you can have a minimal set of a cluster in your local environment in few minutes, and just go for it. And if you're running on the production, just apply good practices over there, like the networking things, like securing the services instead of giving all of the master access or opening all of those things, because one day that is going to be disruptive for the business, and even for the services. So I would say to be extra careful in that. Just give or provide a minimal uses or the minimal privileges for the user for the service, and try to avoid the keys, hard-coded keys, I say. And yeah, and if there is any problem or if there is anything I could help, just reach me out on the social media, Twitter, LinkedIn, anywhere, and I will just be there for helping. Yeah.
Right. Thanks a lot, Raju. So once again, thank you, Raju, and also thank you to all of you who have joined us today. Like Raju mentioned, if you have any questions, feel free to either reach out to him, or you could also just ping us on GDG Cloud KL. We could assist you guys as well. So for those of you who have any suggestions of topics that you would want to hear in our upcoming sessions, feel free to reach out to us about that as well. You can either put it on the comment section or just reach out to us through Facebook. And yeah, I think that's it from us today. Thank you very much for joining, and hope to see you all again soon.
Thank you. Bye
So
bye.
thank you. Bye.